the topic battery energy storage standards that I'm going to discuss now is also a little bit theoretical, you can say. So please bear with this. And yeah, so I would try to give you a snapshot of some insights for the battery energy storage. So those who may be more interested in the details can dive into these standards. But for the today's lecture, I've just kept the scope limited to the kind of brief insight for these standards. Yeah. So first, I'll try to understand that why standards are necessary. Then some of the basic terminology, technical. What are the various technical standard organizations? Standard approval procedure. What are the different approval procedure for the standards? Then we will just see what are the different IEEE, IES, and BIS standards related to the battery energy storage. Then we would cover in detail the IEEE recommended practice for sizing lead acid batteries for a standalone photovoltaic system, and then some performance reporting used in current battery data sheets, some key performance metrics, some observations while seeing into these standards, and then references. Yeah. So first, we all are very aware of this term standard, and generally it comes more when we are purchasing some technical stuff, or when we are designing some device as a researcher or in industry. But if you just see this very short video that I'm going to share now, we would be able to know that not only in the research or in the industry, but in the daily life, we are just I mean, everything that we are interacting, we are dealing with these standards. So, are you able to see, because I have just shared the one application, are you able to see the video now? I don't,
No,
I
not
yeah, just give me a moment. I think, yeah, just give me a moment. Sorry for the interruption. Just a moment.
We live in an amazing world, full of incredible opportunities and endless possibilities. But it can also be a complex and overwhelming place. When things don't work as they should, it often means that standards are absent. But when ISO standards are applied, life is just so much richer. ISO standards help to make the world a safer, cleaner, and more efficient place. From food safety to computers, from healthcare to new technologies. There are many challenges facing our environment, economy, and society. ISO can make a positive difference to all our lives, utilizing a wealth of international experience and wisdom. In today's ever-changing world, ISO standards help create growth, open up global markets, and make trade fairer, including for developing countries. ISO standards can help tackle global challenges like climate change, road safety, energy, and social responsibility. ISO standards touch almost everything we do, keeping us connected and entertained, making us more productive, more creative, sharing ideas, promoting innovation, and keeping us safe and healthy. ISO is the world's largest developer of voluntary international standards, with over 18,000 standards for nearly every aspect of technology and business. For over 60 years, a network of standards bodies in 163 countries, working in partnership around the world and right here at home. ISO builds confidence for today, for tomorrow, and for the future.
Yeah, screen is visible.
Yes, yes. Yes, am I audible?
Yes, you are audible, but I mean, screen is not visible.
Oh, I don't know, just I think now it should be
Yeah, yeah,
visible.
yes,
Oh,
it is visible.
sorry for this interruption. So as we see in this video that standards are kind of in everything that we are either using in the daily life, we are consuming, standards are involved there. Maybe we are not that much observant for this, but still standards are involved in every form and making our life easy. So if we see that something is not working perfectly fine, then that perhaps there would be the standards are not as per the requirement there, or the standards are completely missing in those things. So first, just to have a brief insight that why standards are that much important. So as you first point, like, is the standard reduces the cost, the cost involved for the minimization, like the minimization in the errors, the redundancy that are involved, and it helps to increase the productivity. How? Because like if we have a standard reference specification, or the target line, or the standard is specified that okay, up to this level, if you maintain the quality of certain product, then it is uh, approved, or it is granted, so that it clarifies the objectives, the goal of the design for the designers as well as for the researcher industries. So somehow is it increases productivity and reduces the randomness in the design part. Second is the efficiency, because we have a standard reference line for us to design the products, and therefore it improves the quality, safety, and lead time for products and services. It helps a lot in mitigating the risk, because as we know, in the daily life, if we want to purchase some device, some electronic item, or any other thing, then definitely we first check for the, especially the eatable items, we first check for the ISO mark there. So this somehow is the customer's faith in those standards. And these, if the certain product is as per the design, as per the certain standard, then we are believe that the risk level associated with that particular device or the particular product is relatively very less. So if the customer have a faith, or we can say a belief in a product, then definitely it enhances the business opportunity, it enhances the product visibility in the global market, and it improves the supply chain there. And another fourth point is like consistency. As you see that there are different we will be going to discuss in further slides, that there are different kinds of standards, and which cover the regional area, which cover the national level, or the international level. So in that case, the standards and every geographical location, country, nation have their different requirements, their different geographical surroundings. So as per their need, some localized or some regional changes could be there. But if certain product is standardized as per the global standard, then we understand that there is a consistency, and this consistency basically helps in reducing the research and development cost, and thus it improves the speed speed to market of building on the previously standardized technology. Because like for example, if today's scenario or in coming 10 years, 20 years, we expect that okay, a certain standard should be developed or should be upgraded, then based on the already existing standards, we could take consider them as a baseline, and then we could just update them as per the uh, requirement of the future. So this will rather than just starting from the scratch, so this will basically lowers the research and development cost that is involved in the this development part, as well as if there is a consistency between the standards. In that case also, it reduces the efforts that is put towards the research and development there. Another is like customers' confidence. As we know that if that there are 10 products in the market, and one product is having ISO mark there in the product, another is having maybe Indian standard, another is having another regional standard, then in definite in that case, and some products are having standard mark or the standardization not at all. So definitely maybe with some higher price or maybe at the same price, we would go for the product which have the uh, standardization mark there. So this basically increases the customer's confidence that if certain product is as per designed or developed as per a particular standard, then definitely that product have the specification, the quality level, the safety level as per that standard. So definitely with some the product if have some standardization mark on that, then definitely it gains additional attention in the market. It have more customers have more confidence on such kind of products, and it increases the you can say the market visibility or the sales of that particular kind of product. So that's why it is also important. And uniformity, because like all different countries have different requirements, there are different exemptions, different working conditions, so there is a quite differences in the things. But when we talk about the global standard, the international standards, then things are uniform, unified, and which basically there are some terminology definitions are mentioned, the standard procedure are mentioned. So those standard definitions, uh, steps of calculation, or you can say the procedure of particular development of a particular product or maintaining the quality of a product would be unified, would have the uniformity, so that in that case it again ha- uh, gives the confidence at the international level as well as at the local level for the market purchasers as well as for the uh, market sellers. Another thing is that it eliminate the trade borders, as we have discussed that there could be different needs of the regional geographical regions, countries, but these standardization standards basically reduce these kind of barriers, like the trade borders or the reducing technical barriers to the international market, to the international trade. So this helps a lot because all regions have different kinds of criteria, different requirements, but it eliminate such kind of technical barriers there. And another thing is that universal vendor requirement. So even if you are living in Europe or if you are living in a Asian country, but if you talk about the global standards, in that case it also specify the universal vendor requirement. So it helps industries, companies to or researchers to develop such products according to the vendor requirements, not for the particular region but globally. So these are the some advantages that why standards are beneficial for not for the only the industry but for every common person. And in the last video we have seen that standards are involved starting from our food to different technologies that we are dealing in daily life. So if things are not designed as per the required standard, as per the specification that are mentioned in the standards, then life may get worse in such situations. So here are some very basic terminology. Like if we define standard, then how we can define it. So there are very different definitions available. So I've just taken this definition from the ISO website. So standards are the distilled wisdom of people with expertise in the subject, in their subject matter, and who know the needs of the organization. They represent people such as manufacturers, sellers, buyers, customers, trade associations, users, or regulators. So as you could see here, that there are different stakeholders for the standardization process, like the manufacturers, sellers, buyers, customers, and trade associations. And for instance, there are different kinds of standards. We generally, I'm not taking here the technical kind of, but these are the standards, like for the quality management standard, that in daily life we use in a different ways, like the environment management standards, health and safety standards, that is the most important, and to help reduce accidents in the workspace. Then energy management standards to help cut energy consumption. So there is a long list of standards. Some may be more common, more usable to us, some may be relatively less, but anyhow they are helping us. There are the international standards. So international standard is a kind of document, you can say, which contain practical information and the best practices. So why I'm talking about the best practices, like for example, different it is international standard somehow is a developed of the best, considering the best practices from different standards that are available in that field globally or at the regional level. So it takes best of out of those standards, and it often describes an agreed way of doing something or a solution to a global problem. So yeah, why we are talking it's a agreed way, because it the once the standard is developed, it is open for the public comment, it is open in the public domain. So if you feel that okay, this the specification or the particular criteria that is not mentioned there is mentioned there is not as per the mark, or there is some refinement is required, then one can raise there the point, and then committee can just have the discussion. They can analyze the suggestion that is made by the public domain. So accordingly, if they find the suggestion is good, it improves the effectiveness of the standard, it helps there, so they can just add that. So that's why we are saying it as an agreed way of doing something or a solution to a global problem. Then there comes to as a national standards. You heard of that, means a standard adopted by a national standardization organization and made available to the general public. So these national standards may be completely rewritten, different kind of document, which might take some good practices from different international standards as per the geographical or the local need of a particular country, particular region. So but it depends completely upon the country, their policies, that how they frame the national standards there. You may ask, you may interrupt in between and ask the question if you have any doubt, because I'm just working in the full screen mode, so I'm not able to see anything except the slides. So I'm just wondering that anybody is listening, or post lunch effect is there.
Yeah, definitely I shall let you know. So if anybody comments on the chat box, definitely I shall let you know.
Yeah,
Thanks.
yeah. Thank you, sir. Yeah. So yeah, so here we come with the technical standard organizations. There are broadly we heard of many standards like IEEE, IEC, but sometimes confusion comes that which standard lies in which category, we can say. So here I have just named a few examples there. There is a long list you can search. And so international standard, like for example the IEC, that is the International Electrotechnical Commission, is one of the organization. IEEE, Institute of Electrical and Electronics Engineer. ISO, International Organization for Standardization. This could be the some examples of international standards organizations. And then it comes to the regional standard organizations. For example, like for the Europe region, there are a lot of different regional standard organization. I have just kept two examples here, but there is a long list. And Another is like for Asia Pacific region, there are regional standard organizations which basically focus on not on an individual country but on the region, like the Asian region, like the Europe region, like that. Then the third category falls like the nationally based standard organization. For example, in India, we have this Bureau of Indian Standards. Then for the Netherlands, one organization is there. Then for the Australia, there is a standards Australian organization which even in a country there could be multiple nationally based standard organization. It depends completely upon the organization or the national structure in a particular nation. So these are the three broad categories, you can say: international, regional, and national. So here comes with the standard approval procedure. So this procedure I have just taken a reference from the IEEE standardization process, but there could be a different organization could adopt different standardization process. But if you see more over the broader steps, these are almost similar, but yeah, with different names or some different maybe minute difference in some steps. So here if you could see, like for example, I will try to explain this figure with the help of one example that I am uh, referring from one of the Australian project with the DNVGL. So in the first case, like for example, the initiating the project, like for example, if we talk about the battery energy storage, and we link it with the Australian market. So in that case, if we feel that okay, there is a requirement of certain standard associated for battery energy storage application, or if there is a kind of requirement for upgradation in the existing standard, so in that case there would be a working group would be formed, and this working group would basically depends upon the collaborators who are the different collaborators for this project, and according to that work would be decided. And this working group basically is would be responsible for drafting the standard there. But the procedure from moving to step 2 to step 3 is a quite long, and I must say it is a time consuming, because that working group has to first analyze that if you are want to for example make a battery energy storage standard for the standalone photovoltaic application, in that case what uh, are the existing practice, not in the Australia only but across the globe. So they have to and you can understand there are a lot of country, lot of regions, so you can understand there could be a possibility that hundreds of 200 300 standards would be present there, maybe not exactly associated with that same title, but still associated with the photovoltaics or with the battery energy storage individually, or maybe as a combination of them. So first they need to decide and analyze that which are the standards which are more relevant to their work, what are the market practices in the Australian market, what are the scenario there, what could be the potential for such kind of products if come in the market based on the standard they are planning for the design. So a lot of factors are there, and based on those factors they would be going to decide that okay, uh, we have a lot of standards available globally. We had these kind of different potentials available in the market. These are the current practices. Then they, based on the certain assumptions, certain hypotheses, they would be going to narrow down their search and try to divide those standards and those points in a kind of some classified groups, and then after filtering out the unnecessary. Yes. Okay. So after filtering out the unnecessary information, they could just focus on the standards which are more relevant to their work, and then they have to make a kind of review template. So based on that review template and the format of that review template is very critical in this process, because in the review template they need to specify that what are the parameters they are going to consider for the comparison of different standards. or the review of different standards. So if you are not able to select those parameters very critically, in that case the complete review process would be may it would not be of that use, or the expected outcome could not be there. So based on the review template, they used to review the different standards, and then based on the regional or their like for example in the Australia, their regional requirement, their country level requirement, they could extract the best features out of those review process from the different global standards which are more relevant to their regional or their national requirement. And then based on those extraction of the important features factors, they would be able to present a complete draft for that standard. And in this working group, there could be different researchers, there could be different industry people, manufacturers, depending upon the collaboration they are making for this work project. So once the standard is drafted on this step 3, then that draft is available for the common public, for the, you can say, in the public domain for the comments for a particular number of months. And then in the public domain, different stakeholders can see that draft, can review that draft, then put their comments. And if certain comments come there at that stage, in that case the committee has to analyze, has to visualize those comments, try to understand this how relevant those comments are. And if they found certain good suggestions there, then they generally goes for the modification in the draft. And once those the draft is approved from the public side as well as from the committee, then it went into the final approval process. And then the thing comes with the maintaining the standard. So depending upon the time or the future scenario or the current status, the standard went to the different amendments, different changes or different upgradation as per depending upon the current situation or the current condition. So with the time, those standards could be amended and different updated version of those standards could come. So this is the general process for the IEEE, and similarly other organization can have their own structure, but moreover the idea remain same here. So here I've tried to this group different battery energy storage standards which are available with the IEEE. So I've just tried to this is not a kind of standard categorization that is available within IEEE. It is something that I've tried to just show you a picture that what kind of different standards available in IEEE which are associated with the battery storage. So here you could see the first, like the battery storage, energy storage. This is a standard which is basically related to the, you can say, the individual battery, like what are the related to their chemistry, they are related to their internal operation. So here these standards, only two standards are present there currently, which are basically related to individually the battery, not related to the any other application. Then there is a long list of standards which is associated with the stationary application. So you can see here some applications are good grouped together rather than focusing on them individually. So there are a lot of standards which comes under this category. Then the standards for the power plant and substations, and for the nuclear power plant, electric power system, and the photovoltaics are segregated in different categories. Here you could see. So for the photovoltaic, like for example here yeah, so here for the photovoltaic system, you can see like 22 to 31, that is completely almost nine standards are there. Some standards are currently active, some are not inactive, or already gone kind of standards. But till now total in IEEE, you can say there are 9 standards are framed which are with reference to the photovoltaics. And similarly there are some references for the remote hybrid power system and then cycling surfaces. So here you could see, if we talk about the battery energy storage with reference to photovoltaic system, which is a kind of current need here, as well as the remote hybrid photovoltaic power power system. So a lot of standards are available here in the IEEE with reference to photovoltaic systems or the remote hybrid power system applications. So being an electrical engineer, we have a kind of good uh, number of uh, these IEEE standards related to battery energy storage, which are falling under the different categories. And this kind of categorization, you will see in the coming slides, that is not available with other kind of standards. So this is something that is a plus point, I can say, here with IEEE standards. Then moving to the next slide. Yeah, so here in the IEC standards, you could see here the this diagram, or this the category division is relatively reduced here. So here in the IEC standards, there is like one category is similar, that is a battery energy storage, but you could see here relatively large number of standards are available which are related to battery itself. And for the photovoltaic, here especially I've marked this photo for the photovoltaic and battery energy storage combination. There are only two standards that are present, so they are very I must say, they are very straightforward here in this condition. So you could see that one standard is completely focusing on the photovoltaic off-grid application, and another one is focusing on the on-grid applications. So if you are a researcher who are working in maybe like microgrid, off-grid, or standalone microgrid, or the on-grid applications of photovoltaics, so in that case, I think this is something IEC standards are giving very clear picture here after the IEEE standards. And then they are focusing on the electric vehicles here, and this is something which we have not seen in this. Here you could see that after these some applications, the other applications are completely fall in one category, that is the stationary applications. But here we see that they are especially focusing on the electric vehicles as well as the industrial applications. And one new category that I've seen in this IEC standard is for the railway applications. So here in the IC standard, you could see that they have a kind of battery energy storage for some specific application, mostly focusing on some specific applications that is related to railway or the industrial electric vehicles photovoltaics as compared to the IEEE standards. So here we comes with the Indian standards. So you are able to see that a lot of different categories I've tried to mention here. So this is because Indian standards focuses on these particular applications individually, not kept them for in a broader category. So this is first for the energy storage, and you could see here a long list of the standards which are related to the battery itself, like the battery, the operation of the battery, the working or their chemistry, chemical reactions, their chemistry, such kind of things are there involved in this battery energy storage. And so these large number doesn't mean that there are kind of different standards, but it means that a lot of upgradation, a lot of changes, or the new version of the standards comes with the type. So as time moves from, so there are kind of lot of upgradation happened in the battery energy storage in case of Indian standards. And another you could see here the generating stations, and there is only one standard. I'm a bit surprised, I'm not sure, maybe I have skipped something there while viewing this, but I'm surprised to see that there is only one standard here with the generating stations. Another is for the photovoltaic system. Again, it comes with a surprise that we have only one standard here. I've just intentionally mentioned the name of the standard, which is basically related to journal requirement and methods of test. That's it. So it doesn't talk about on-grid application, doesn't talk about off-grid application or the hybrid application. Fortunately, on which generally we are working nowadays. So it doesn't say anything about those kind of application especially. It just says a kind of uh, application of the battery storage with photovoltaic with just a journal requirement or the method to test them. So it's a bit surprising, but yeah. And for the vehicles, they have different standards. Like for the normal vehicles, conventional vehicles, they have a different set, and for the electric vehicles, they have a different sets here. And then the good part is like, okay, like the IEC standard, we have industrial application, we have standards for railways, for marine application, for aircraft. So you could see that different uh, here the application list is more than the IEC standard. So I can say that because this Indian standards are basically a combination of IEC standard and IEEE standard, you can say. And we in the Indian standard, we try to adapt the good uh, practices of those all these IEC IEEE standards as per our geographical and regional requirement. So yeah, so if you are interested or working on the photovoltaic kind of application with related to microgrid or the grid connected, that kind of stuff, then you can look for the IEEE standard or the IEC standard. Yes, so I just tried to write down some names here, which are the active standards in photovoltaics with the IEEE here. So these are the some installation standard related to the installation and maintenance with the photovoltaic system. And another separate standard is related to the sizing of lead acid batteries for such standalone application. And that this is something that I found interesting here, because if generally what I've seen that sizing is something that I mean in the research, at least sizing we just I mean not that much serious about that those standards here. So if you are working with the sizing of such kind of batteries, so you could have a see on this second number standard. And then these are the some standards which are almost at the age of, and these are just these two standards are just the modification of these standards. So these are the active standards here. And so what I have done here, I have taken this standard, this second number standard, which is related to the sizing lead acid batteries for standalone alone photovoltaic PV systems, and just try to take the main points here, or you can say the main steps here, so that you could have an overview of how this all works. Yeah, so here one thing before I start with this IEEE standard for sizing of lead acid batteries for standalone photovoltaic system, one thing that I found very interesting about this IEEE standard is if you open the standard, in that complete steps are given how to size a battery perfectly. And if you and those steps are not, I mean, it's a very only 5 steps are there. So if you follow those 5 steps very carefully and mention the values, calculate the values critically, then your battery size would be kind of not exactly the optimum, but it would be as per the standard. And another thing that is I really liked about this standard is a lot of examples are given in this standard there. So if you uh, there are a lot of example based on the different conditions. So for example, if you are calculating something for a refrigerator who is which is capped at a far location, remote location, and you want to design or size a battery for that kind of refrigerator, maybe which is running based on the some photovoltaics. So for that kind of application, what should be the steps or what should be the important points? And if you are designing batteries, if you are sizing a battery or designing a system for a house in a remote area, then what could be the parameters for that? So different examples with calculations are basically provided in that. So you could just if you are not sure with the literature that is available in form of different papers, because if you see in the different research papers, due to the limitation in the number of papers in the published article, the complete calculation or the complete steps generally are missing. So I found this reference, this standard is a very good source of such kind of material where you could just have a look in this. And so this some overview about this reference. So it is basically determine the appropriate energy capacity of a lead acid battery. That's it, with particular application of a standalone photovoltaic system. So this is the scope. This is the objective here for this standard. And one important thing is that it assumes that no power is available from the array. So if your system is you can say the grid interactive kind of system, in that case you have to do a trade-off there in the sizing, because the calculation which is presented in the standard, it assumes that there is no power is available with the such kind of PV array and no other power is available. Then in that situation, what should be the battery size? So definitely in that situation, the battery size would be relatively higher as compared to the grid interactive system. So you should check that what kind of application, for what kind of application you are designing it, and accordingly you can make a kind of trade-off between the things. And yeah, so here you can see the scope. The scope is, it is only limited to the vented or the valve regulated lead acid batteries, and nothing is considered related to the installation, maintenance, safety and testing consideration related to the other kind of batteries. So it is only focusing on these two kinds of batteries here. And the sizing here, which is considered for the battery, is only limited to the standalone photovoltaic application. Nothing like hybrid or the grid connected application is included or the considered in this standard. And then the this is the remainder of the electrical systems, like for example the other electrical uh, loads or the other electrical devices which are associated with the system, are not included in this standard. And the other important thing is that the size which you would be able to uh, decide for the battery would not be the optimized size, because here one thing which is missing with the standard is that the relation between the, or the dependency between the battery size, PV array and the weather is not considered in this standard. So if you would not be able to claim that your battery size is optimum, but at least you can claim that your battery size is as per the standard. So this is the kind of system which is considered in this standard, like this PV array here. And then this could be your DC-DC converter, or the voltage regulator here. So maybe it work on MPPT because the battery is here. And so this is your batteries here, which could be a combination of series parallel batteries, and then inverter just to feed your AC load. And this is the, so this is the kind of system which is considered for this standalone photovoltaic system in this standard. And this is the, you can say, the methodology which this standard uses to decide or to design the battery size. So here you can see the first step is the autonomy considerations. What are the interdependencies here with the system? So all those points come here with the autonomy considerations. Then load determination, what could be load here? So it is not only related to the peak load, but different parameters are there which we are going to discuss. And then battery capacity and functional rate are determination. So what trade-off you want to keep with the battery capacity here, so that comes here with this step. And then based on the capacity or the trade-off or the backup that you want to consider, you could decide the number of determine the number of series connected cells here. And then finally this comes with the battery size determination, and then battery sizing worksheets. This is something that I've told you, that different examples are given with some calculations. So this standard finally concludes this document with the battery sizing worksheet. So this is, I really found very interesting. You could just have a look on this standard. So these are the different autonomy consideration, like what kind of dependencies are there, like the solar irradiance variability is there, system availability, that what would be the minimum number of hours for which a PV photovoltaic would be available for that particular location, and what is the predictability of the load, what is the dependency of their load, or what is the accuracy of that predictability of the load. Such kind of parameters come here. Then recharge capability, that how much you can say the If the array is insufficiently sized, or if the variable available recharge time is too short, in that case battery may not be fully recharged. So it depends upon the location, that what are the irradiation, what are the photovoltaic power generation there, and according to that you should decide that your at least the capacity should be such that your battery could completely charge in between the time. And accessibility of the site, that even if there is a worst condition, then what could be the what is the distance of that site location, so that you could physically go there and correct the things if something worst happen. So these are the some certain dependencies that you need to decide, or you need to make a trade-off between the these decisions here. Another is you should follow a systematic approach. Generally what I have seen here, we doesn't go for these different dependencies, and we just check for, okay, what is the peak load, what is the kind of thumb rule there, like, okay, battery should be this much percentage higher for this PV capacity. So we should not go for that kind of thumb rule, but we should critically analyze these things, these parameters, and then decide the different dependencies there. And so this is the load determination. So not only the peak load, but you need to consider a lot of parameters here, which I mentioned on the screen as per the standard. So you need to mention all those values, like what is the momentary current, what is the generally the running current, or the load duration, what is the load consistence. Like example, if there are 10 loads are associated, then what is the possibility that all 10 loads are on at a particular time, and what could be that duration. So you need to critically look all on these all the parameters. And then these are the some parameters related to the battery itself, that what these are basically including with your state of charge, and like the what are the temperature adjustment, some design margin that you want to keep there. So these are the battery type, what kind of battery you are want to use for that particular application. Then based on these consideration, like we have uh, discussed for the dependencies here there, then we have discussed identified the load, and then the battery type of battery, then it comes with the what number of series connected cells should be there. So that series connection basically depends upon the nominal system voltage, what is the nominal system voltage. Then it depends upon that calculating the number of series connected cell based on the maximum number of cells allowed, how much what could be the, like for example, if we are designing this battery energy storage system for a particular location, that what could be the physical size or the location, what could be the volume is available there at that particular location, what is the end of discharge voltage there. So these are the different parameters that we need to consider while designing with the number of batteries for the series connected. Not only the nominal, generally we go for this voltage only, what I believe, that we just check for, okay, this is the nominal voltage of the system, and accordingly we just calculate and decide, but this should not be the practice. And then this is the last fifth point, the last one. Then finally it comes to the battery size determination. So you need to check that, okay, this is the individual size of a particular battery, then number of parallel strings, series we have already decided, then final number of cells. So you could see here that first we decide with the capacity, then we decide with the number of series connected batteries, then it comes with the parallel, just to cope up with the overall capacity of the battery. And then there are check and considerations. So we need to check, like under discharging conditions, high discharge rate, freezing of the electrolyte, and the self discharge of as a battery load. So these are the some parameters that we need to check before finalizing all the things. So here these are the 5 steps, you could say, and after these 5 steps there is a kind of detailed document is given for explanation of these each and every point there. And then the sixth step is the basically the worksheets. So I feel that you could just go with the first to 5 points to understand them in detail, and then with the sixth step, that is a worksheet, you could practice there with the sizing of battery. And really it's a very good I mean a lot of good examples are given there for different kinds of situations, so you could have a and the document is very easy to follow. So again, the performance reporting used in current battery data sheets. So you could see here this these are the different things that are mentioned on the data sheets. Like example, there is a kind of variability among the different manufacturers. Absence there is a lot of observation is related to the absence of a standardized methodology. Like different companies are mentioned different kinds of points or specification in their batteries. So there is lack of, you can say, the standardization process or the methodology which relates the measure, quantify and document related to the battery performance. And there is also a lack is find related to the measurement method, because there is a kind of a lot of impact based on the kind of method that you are using for measurement. So this is something which we are lacking in, and the consumer confidence is required to fully realize the potential of the residential small commercial battery storage market. So this is the one of the key factor, but still the information to the consumer is uh, missing here in the, because it is not uniform, so that customer is slightly confused that which is the optimal technology, because there is nothing to compare. Every manufacturer have some different kinds of format or some different way of mentioning the specification without mentioning any detail of the measurement method. So these are the some limitations we can say. And then key performance, as I feel that we are running out of time, I would just try to uh, just scroll the slides with the main conclusion here, so that you could just have a look later on. So the key performance metric here is the energy capacity. So here uh, these the conditions should be quoted by the manufacturer. Like for example, what is the energy capacity, what is the usable energy, because generally the manufacturer mentions the normal uh, energy value here but not the usable, and the usable energy is relatively lower as compared to the normal energy. And there is a dependency on the charge and discharge cycle with the temperature. So such kind of things are not clearly mentioned in the manufacture by the manufacturer. So this is a limiting parameter. Another is the lifespan. So some manufacturers mention that technical life is span, and they also not include that the if what do you exactly they mean by the cycles, because cycle as at 100% SOC would be different as compared to the 10% SOC. So this is something which is not common in this battery energy storage industry, and we need to look upon them. Another kind of standard that lifespan that some manufacturers mention is the warranted lifespan of the BES. So in this case, they just mention based on the calendar life, nothing about the operation conditions, but these operational conditions are basically the hidden parameters there. So hence it is common for variances between the technical and warranted lifespan of a system to exist. So we need to carefully look into this matter also. Another is related to the efficiency. So here it is important that efficiency which is mentioned should be the round trip efficiency, which means that you start from the battery point going to the load and again from the load to the battery. But generally this is not the case. We just consider the one-sided, you can say, rather than the round trip efficiency. So this is something also very critical to look into the when you are purchasing with a battery. And another is the environmental operating conditions. So here you could see that a lot of things which affects the performance of the battery, that is the temperature, relative humidity, operating altitude. And here a very confusion about this temperature is there, because the temperature uh, doesn't have impact on the you can say about the hardwares which are associated with the battery, but it affects the it influences the performance matrix of the battery itself, like the cycle life, capacity, power, etc. So generally the good practice would be to dictate that that temperature be measured at the cell level, but in a routine case it is never mentioned there in the manufacturer. So this is something which manufacturers are fooling us. And another thing is that environmental operating conditions. So here, very you can say a big gap between these environmental operating conditions, because generally if we talk about the temperature, what is the temperature? This is ambient temperature, but ambient temperature of what? It relates to the cell, it relates to the battery, or what? So you need to check with those kind of environmental operating conditions. So here I've just tried to made some observations. So first observation of mine, it is completely what I have seen. So it may be not be 100% correct, but it is something that I observed, that there is a lack of standardization. You could see here, you could see in the last slides that there is a kind of IEEE is having different kinds of structure, IEC is having different, our BIS's standard is different. So even if in Indian standards we want to follow a standard for the off-grid application, as we have seen, there is no such a standard. So this is something, there is a lack of standardization, you could say. And there are a lot of significant documents related to the battery energy performance, but there is a lack of synchronization, you can say. How to define, how to measure, report battery for performance characteristics, such kind of things, details are missing in those documents. And another thing is that many standards are basically mainly focused on the technology or the chemistry specific, or not may capture the full requirement. Full requirement here means based on the how to reflect the BSS performance for today's use case scenario. So, and the last important point that I feel is there is a lack of global harmonization. So the every region, every country, or they are following some, I mean, they are just focusing on some specific application. So there is a need of global harmonization, and a good initiative is done by the IEEC committee here, with this standard series with the Pacific Northwest National Laboratories. So in this reference, so they are working towards the developing the standard for energy storage system. But such kind of global harmonization activities are very few, and there is a requirement to have such more activities in future. So here you could see that there is a range of applications that could potentially be adopted by different consumers, like for example virtual power plants, or network providers, including embedded network providers. So these application will lead a number of different battery energy storage or charge or discharge profile. So here this is something important, that depending upon the application, the charge or discharge profile of the battery would change. So we need to see that in, okay, in a particular country, what kind of applications have more market, or the more requirement in nearer future, and accordingly we need to update our standards, such that we could consider such the difference in the minute technical details of such kind of applications. And there is a limited information present within the existing literature in relation to BES applications that we have seen, and it is true for different countries. And consistency is something that is very important here, which we feel that is missing. And I think here we comes with the end of the presentation. So there are a lot of references here in the slide. I've just added here the hyperlink, so you could just click on them and go for the relevant standards. So these are the different standards which I have tried to categorize in terms of IEEE IEC standards there in the slides.